All right, so in this particular problem, this texture looks like it's concrete. So this is all solid, singular piece. So if you had to think of a connection type for B, you probably want to say that's a fixed connection. And if you look down here at A, you can see there's no indication that there's any kind of movement there at all, rotation either. So we'll assume A is also fixed. And then you've got this distributed load acting all the way across the upper surface, and then a little point load on the side. I just wanted to show you those. So let's draw the free body diagram for that. So there's my dimensions. The thing is 10 feet tall. This little overhang is 3 feet. This is 12 feet. Now on the end, I do have an applied load that I don't have to do any work on. It's just right there. That's 5 kips. Now I'm going to take this distributed load, and I'm going to make a concentrated equivalent for that. Again, it's a rectangle, so it shouldn't be too hard. It's just going to be the dimension of the base times the height. The dimension of the base seems to be 15 feet. So 15 times 0.6 is 9, I believe. Is that right? Yeah. So there's my concentrated equivalent force of 9 kips. And it's going to be applied to the centroid of the body. And the centroid of a rectangle is right in the middle. It's 15, so that'll be 7.5 from each side, right? So that would be 7.5 here. And if I take 3 off, this little piece would be 4.5, and then this would be 3. So there's 7.5, 7.5. So there's all my dimensions that I might make. Now I'm going to make assumptions for my reactions down here. So that's going to be point A. So I'll assume up for my y direction, to the right for my x direction. And again, I'm using right-hand rule, so I'm going to assume there's my positive moment at A. Of course, you can choose different ones if you like. That's not that important. But I think whatever you do, I think consistency is one less thing you have to worry about in the exam. Kind of what you experienced on the quiz, on average, you've got about 15 minutes to work a problem. And it's a pressure situation. You have a time limit. So anything you can do that's routine and that's comfortable is going to help you out in the long run. So again, that looks pretty good. In this situation especially, summing moments at the connection really helps you out. Again, you'll notice that AY and AX would be concurrent at A. And when you sum moments at A, you would have the unknown moment in terms of all the things you do know. So again, we're going to sum moments at A. So again, I'm going to assume right-hand rule for my sign convention. We'll sum all the moments that occur about A, and we'll make sure that's in equilibrium. So there's your statement. So let's begin. So with my sign convention, this moment at A is what? Positive or negative? Positive. So I'll just write MA. Now, what kind of moment does this 9 kip force create about A? Positive or negative? Negative. And it's force times distance, so the force is 9 kips. And what's the distance between A and the line of action of the force? 4.5 feet. And now we've got this 5 kip force. Again, as it rotates around A, it's going to move what? It's going to be opposite my sign, so it's going to create negative moment also. And again, force, 5 kips. Distance, the distance here is 10 feet. So I can solve for my moment at A. It looks like my moment at A is going to be positive. I don't know what that's going to be. 36, 86, 88, I'm guessing. 108. Something with an 8. 99? 90.5? Well, that wasn't an 8, was it? 90.5. And that's going to be kip feet. Don't forget the units. So it came out positive, so what does it mean? I assume the right direction. All right, so now I'll do the next one. I'll sum forces in the y direction, and I'll assume up is positive. Now, you don't have to do this. I always do this so that when you look at this later, it's clear what I chose, and also it just reminds me. Anytime you write something down, we've got that connection between writing something down in our brains. Usually when you do that, it makes some kind of even short-term indent in your thinking. It keeps you kind of sharp on your accounting. So looking at that, I've got AY up, so that's positive. What else is in the y direction? My force 9, it's acting down, so that's just 9 kips. Is that it? Oh, that's pretty easy. I can solve that. AY is equal to 9. And again, it came out positive, so again, up is the right choice there, or the correct choice. And then finally, our last equation in our coplanar system, we're going to sum forces in the x direction. Make sure it's in equilibrium. I'm assuming right is positive. So my AX is positive. And then what else is in the x direction? Oh, this 5 over here on the corner. Is that positive or negative? Positive. So when I solve for AX, I get negative 5 kips. Now, we've been trained in our lives, and I'm going through this now with some of my kids, that negative is bad. Negative is bad. Like in your bank account, negative is bad. All right? In structures, negative is not bad. Negative is just the opposite direction. That's not a big deal. So if you get a negative force, oh man, I messed up. I got a negative force. I need to turn it around. No, you don't have to turn it around. It's direction. It's not on a number line. Negative 5 is not less than positive 5 in our accounting. 5 is 5. One is to the left, one is to the right. That's all it means. Now make sure you remember that when you're plugging that into your calculators or trying to do something on a graph. Just keep aware of what you're trying to do. All right, any other questions? That was pretty easy too. Okay.